subscribe this channel for more videos and updates. Watch till end for the project documentation and inputs for resume building. Sample data sets are provided in the description below. And we offer the services, training and mentorship, hands-on live projects, resume building, interview preparation, and more. For any queries, feel free to reach out to us, dataanalyticsandbi@gmail.com, or you can also call this number. Hi all, welcome to Data Analytics and BI. In this tutorial, we will discuss about one of the most important topics throughout the databases and also in Power BI is data modeling. Why do we go for data modeling? So why the data modeling is important for analysis in Power BI or in SQL or in the data visualization part. So first of all, what is data modeling? So in the previous videos, in the previous session, we discussed about the difference between the dimension table and fact table. So the data is being divided, the tables are being divided or segregated into dimension table and the fact table, the master table. So why it is divided into dimension and fact table? In order not to put a lot of load on the data, on the server or any application that we use. So the data is being divided into dimension table. So what is a dimension table? Dimension table contains all the descriptive information. All the descriptive information about the fact table. Descriptive info about the fact table. And what do we have on the other hand? We have the fact table. So what do we have in the fact table? Transactional data, complete transactional data. So the dimension table would have the primary key, and the fact table would have the foreign keys. Just remember dimension DP, dimension primary key, and fact table foreign key, FF. So here if you take, so let us consider few tables. So here comes another concept called as a schema. So we have a concept. This data modeling can be done on the basis of schema. What is a schema? The schema is like blueprint. So how does the data need to be flown, passes through all the tables? So schema is like a blueprint. How the data is arranged, how the tables are arranged. So this is based on some certain rules for sorting the data, for aggregating the data. So this is schema is required. So in here, what we do, so we have few tables. For example, I have a table called as a transactional table. So here we have a table called as a transaction table. So I can simply say the revenue table. So what does the revenue table contains? The revenue table contains so the fact table will contain the IDs, that is foreign keys. Product table, product ID. So branch ID, and also we have date ID. So here what do we do? So we have like quantity, price, unit sold, revenue, discount. So all this information. So this is in the revenue table. So now let us take another table. So what do we have in another table? So we have customer table. We have another table. So other tables. So let me take other tables. So what do we have in here? So here we have a customer table. So customer ID, customer table, customer ID, customer name, customer address, for example, address. So customer name and customer ID. So here what do we have? So we have product table. So what do we have in the product table? Product ID, product name, and product inventory. So where does the product is coming from? And here what do we have? We have the branch ID. Okay, branch table. So branch ID, and branch name. And here we have the date table. date table. So we have date ID. So date ID, year, month, quarter, year, quarter, month. So we have all these information. So if I want to know about who is the customer, what kind of a products does the customer bought, and which is the branch, and what is the year, quarter, month, and all these information. So I need to make the relation between the tables. So how do I make the relation between the tables? By using the customer ID. So by using the customer ID, I'll make the relation. So using the customer ID, I will make the relation. And also we have product ID. So from product ID, we have the product. Okay, we have the product ID. And the next one is branch ID. So from the branch, I'll get to know what is the branch name. And from the date ID, I'll get to know what is the date. Okay, what is the date? So here I'll get to know. So I can pull the information about the year, quarter, month. So I can pull the information. So I can pull the information from the customer. I can get the customer data. So customer data. So I can pull the information. So here, what is the direction? And how do you want to make the direction? Okay, do you want to make it a single direction or both direction? Whether it is a many to many relationship, one to many relationship, and any other type of cardinality. So here we have a technical information, technical data, technical terminology like cardinality. Cardinality. So what is a cardinality? Type of relationship. Type of relationship. And the next one is cross filter direction. Cross filter direction. What is a cross filter direction? Do you want it as a single direction or a both direction? Single direction or both direction. So here, if you take, whether do we want to have it as a single direction? Okay, single direction or both direction or both direction. So what is single direction? What is both direction? So whether do we want to have it as a single direction or both direction? Just a second. Single direction or both direction? Both direction. So single direction means the customer ID or the customer details, the dimension table can filter the fact table. Both direction means the the fact table can also filter the dimension table. Or here, if I want to know the customer ID and the customer name, okay, and I want to see when the customer bought the data, the products. Okay, when the customer bought the products. For example, I made the both direction. Okay, here also I made both direction. Okay, so here I did not make the both direction, but I only made a single direction. When I made the single direction, okay, I can get to know the customer name. Only I can get to know the customer name and the information from the date table. I may or may not get the information about the date table. What is the customer? Which day the customer bought, or which year, which quarter, which month the customer bought the product. If I make the both direction, I can get to know that, okay, I can also get to know what is the customer, which day or which month that the customer has bought. So this is the data modeling. So we make the relation between the tables in such a way that the data or the column flow in between all the tables based on the cardinality and cross filter direction. Okay, based on the cardinality or cross filter direction. Let me take a new one. Okay, let me take a new one. So there are four types of relationships. Okay, cardinality. So cardinality is, there are four types of cardinalities. The first and foremost one is one to many relationship. One to many relationship. What is one to many relationship? So the dimension table contains unique records. Okay, unique records. Dimension table contains unique records fact table contains multiple records, multiple related records. Okay, multiple related records. So this is one to many relationship. Okay, and the next one, and what is the next one? Many to one relationship. Many to one relationship. What is many to one relationship? Okay, it is a vice versa of one to many relationship. So fact table contains multiple related records, and the dimension table contains unique records. Okay, this is many to one relationship. And the next one, okay, and the next one is one to one relationship. And the next one is one to one relationship. One to one relationship. Both fact and dimension table. Okay, both fact and dimension table. Dimension table contains unique records. Okay, unique records. Then it is called as a one to one relationship. And the next one is last relationship is many to many relationship. Many to many relationship. So what is many to many relationship? So when we try to combine two fact tables, when we try to make the relation between two fact tables, we may face many to many relationship. Or the dimension table sometimes contains the multiple related records. Both the table has multiple related records. Multiple related records. Then we get many to many relationship. So we need to avoid many to many relationship because we may or may not get the transaction data correctly. Okay, this is cardinality. And the next one is, okay, and the next one is cross filter direction. Okay, and the next one is cross filter direction. Cross filter direction. What is a cross filter direction? The cross filter direction, do you want to have it as a single direction or both direction? And the next one is active properties. What is active property? Do you want this relationship active or inactive, or inactive or deactive? Inactive or deactive. Now let us see one example in the practical. Okay, so let me get the Excel. Okay, let me get the Excel. So let me get the sales so that we will get. So sales. Okay, let me click on open. So let me click on all the sheets. Let me click on all the sheets. Click on load. Now the data is getting loaded. Now the data is getting loaded. Yes, the data is loaded. So now let us see what is the data that we have it in the table view. So in the calendar table, what do we have? We have the date key, what is the year, quarter, month name, month number, fiscal year, fiscal quarter, all this information. In the product data, we have the list of products. What is the product name, category, and subcategory. Next one is sales table. So we have the transaction information so that I can get to know unit price, order quantity, total product cost, sales amount. So I can we got to know that okay, this is the fact table. And the next table is territory table. Okay. So what is the next step? For example, I go to data visualization part. I clicked on table. Okay, table visual. So what I need to do, I want to see the sales. Okay, I would like to see the sales. Okay, total product cost by the product. Okay, by the category. Okay, total data of product. So let me increase the font size. Let me increase the font size. Let me increase the font size. Now if you see, so accessories, the same number, 172555318. Bikes, it is same number. So it is not getting segregated. Okay, the data is not getting segregated. So what it is giving? Can't determine relationships between the fields. Click on see details. Okay, can't display the data because Power BI cannot determine the relationship between two or more fields. So I'm not able to get, I'm not able to see the category wise product cost and total sales amount. So how can I overcome this? So we can overcome this by making the relation between the tables. So how do we make the relation between the tables? Go to modeling. We have an option called as modeling, add, edit, or remove relationships between the tables. Click on manage the relationship, click on new relationship. Okay, it is same like the way we did join kind. Okay, it is also the same thing. Okay, from table, what is the thumb rule that I explained? From table should always be the fact table, sales table, to table. So let us, we are trying to make the pull the information from the product table. Okay, product key and the product key is the common column between two tables. That is, product key is the foreign key in the sales table, product key is the primary key in the sales table. And if you see the cardinality, so what is the cardinality that we have? Many to one, one to many, one to one to many, and many to many. Power BI automatically identifies the cardinality. There is no need of making other cardinalities active or deactive. Based on the data available in the sales table, fact table, or the dimension table, it automatically assigns the cardinality. So many to one. Why many to one? The sales table has multiple transaction details, so that is the reason it has many. And the product table is the dimension table, that is the reason it has single one. Okay, make this relationship active. And now for now, let us go with single. We will see why we go for single or bidirectional. Click on save. Okay, I made the relation between these two tables. Now you see the data is segregated. Now you see for accessories, the sum of total sales is 5722. You see, the sum of sales is. Let me remove this for bikes. So we got the data. Okay, so let me make it. So let me take the unit price. Okay, so let me make it sum. Let me take this off. Okay, for accessories, the sum of unit price is 547690. Bikes it is 2623272. Clothing it is 263. Now the data is getting segregated. Okay, now the data is getting segregated as per the accessories, as per the category. The data is got separated. Now you see sum of total sales amount. So we got the data. Okay, now we got the data. And what is the next step? The next step is I want to see the territory by region. I want to see the data by region. Same thing, can't determine the relation between the tables. So what is the thing? Go to modeling, click on manage relationship, click on new relationship, from table sales table, to table territory table, automatically it identified, and many to many, many to one relationship, and cross filter direction is single. Let me click on OK. Yes, I have got the region wise sales also. And what is the next thing? Go to model view. We made the relation between the sales. So let me make some little arrangements. Just look like star schema. Okay, let me pull it over here. Okay, so calendar. So I want to see the calendar data also. How do I do the calendar? So I can make the difference. I can make the relation between date key. Do we have the date key? No, we do not have the date key, I think. Okay, how do we make the relation between the calendar table and the sales table? Drag. Another way of making the relation between the tables is drag the date column from the calendar and drop on the order date of the sales. So now if you see one to many relationship and it is a single, let me click on save. Yes, everything you can see the properties. Okay, in the properties, it is single direction. Here it is a single direction. Here it is a single direction. So now what do? I will take a new table, new page. Let me get the category. Okay, let me add the category, not the category. Let me take the subcategory. Okay, let me get the subcategory. And here from the territory, let me take the region. Okay, from the, so let me increase the font size. 15. Here also, let me increase the font size 15. Okay. So what do we have? So when I'm clicking on big shots, okay, when I am selecting big shots, bikes, bike stand, bottles and cages, so the region is not getting filtered. For example, let me filter Australia, Canada, Central, France, Germany. I'm clicking on it, but the subcategory is not getting filtered. Why? Why the subcategory is not getting filtered? When I'm trying to filter the brakes, caps, chains, cleaners, the region is not getting filtered. Why? Why the region is not getting filtered? What could be the reason behind it? Okay, what could be the reason behind it? So, what is the cardinality? What is the cross filter direction that we have? Single direction. Okay, what is the cross filter direction? Single direction. So, let me take new one. Okay, so let me take the same tables. Okay, for example, let me take one example. Okay, let me take one example. So I have two buildings. Okay, I have two buildings. So here also I have two buildings. Okay, block A, and here it is block B. Block B. So you try to understand why the single direction makes such impact. Okay, I have I have a bridge. Okay, I have a bridge. Okay, this is a bridge. Bridge. Okay, I have a bridge or any path. For example, I have a path. So, so what I did, we made single direction, single direction. Okay, we made single direction. Okay, what is that single direction? So we made the cardinality as a single direction. So the from the block A, I can get into this bridge. Okay, from block A, I can get into this bridge. Bridge. For example, this is a bridge. Okay, from block A, I can get into bridge. From block A, I can get into bridge. But when I am trying to get into block B, I'm not able to get into block B because it is locked. Okay, this one is locked. I have locked. So I just put lock. So what I did, I logged it. I logged it. Nobody. So from the block A to bridge, people can enter. Okay, from block A to bridge, the people can enter. But from bridge to block B, the people cannot enter because I have logged. So same thing here. Okay, what is the same thing? I can enter, the people can enter from block B to bridge. People can enter from block B to bridge. But here the same thing. So what is the thing? I have logged. People cannot enter block A. I have logged it. I have logged it because only single direction. So what is a single direction? From block A, the people can enter into bridge. From block B, the people can enter into bridge. But they can't. The people from the block A cannot enter into block B. The people of block B cannot enter into block A. Because what is the reason? The reason is I made single direction. Okay, I made single direction. So this should be this direction only. Okay, only single direction. Okay, the people from block A can enter into the bridge. The people from block B can enter into the bridge. So what I did, I made the line. Okay, I made the wall. Okay, this is the wall. They can enter till here, and block A also they can enter till here. They can enter till here. Block B they can enter till here, until and unless I unlock this. Okay, how do we unlock this? This can be unlocked by both direction. Okay, this can be unlocked by both direction. So what do we need to do? We need to make the direction both. Okay, we need to make the direction both direction. So by using the both direction, so I can take this off. Okay, I can take this off. The people from the block A can enter the bridge and also into the block B. The people of block B can enter the bridge and also the block A. How? So I can make the cross filter direction as both. Okay, the data from this travel into sales, and sales travel into calendar, and also from the calendar, from the sales, the data travels into territory, and the territory travels into sales. Okay, this is single direction. So but the territory data, if it needs to travel to product, how does it travel? By both direction. Okay, by both direction. Now let us go to report view. Now if I take this off, let me click on Australia. Now you see the data is getting filtered. Canada, the data is filtering. Central, the data is filtering. France, the data is filtering. Germany, the data is filtering. And if I click on anything, Jersey, the data is getting filtered. Lights, locks, mountain bikes. Okay. So based on the cardinality, okay, based on the cross filter direction, the data can travel. Okay, the way we have the locks, okay, the way we have the locks. So when we make the direction as both direction, the data can travel in between all the tables. Okay, I can get the data, I can see what is the territory, which territory has more products sold. I can see the information. What is the reason behind it? The main reason behind it is the cross filter direction. Now I can simply filter the data. Now I can add the data over here. Okay, I can go to sales, I can add the total sales amount. Okay, and if I click on Australia, I can see the Australia's data. Okay, it is getting filtered. If I do not make the relation, okay, as single, if I only make the direction as single, it may or may not filter. Okay, so let me do one thing. Let me go here. Here also let me make single direction. Okay, so now let me filter the data. Okay, now let me filter the data. It is not getting filtered. Okay, so let me add the total sales amount. Okay, if I click on this, it is getting filtered. Okay, if I click on bottles, caps, okay, so let me also do one thing. Here also let me not take the single direction. Okay, it may or it may not filter. So the direction is important to filter the data. Okay, so most of the times we make it both so that the data travel between all the tables. How does it travel? The data travels based on the primary and foreign keys. Okay, the data travels based on the primary and foreign keys. How? So I can keep the keys. Okay, I can keep the key. So how does it travel? Product key. Yes, we have the product key, and from here we have the product key. Yes, the data is matching 214 214, and the sales territory key. Yes, the sales territory key, it is matching. I can also add sales territory key 123 based on these keys. Okay, based on the primary and foreign keys, the data travel between all the tables. So this is about data modeling part. So this data modeling can be used for further analysis, implementation of the DAX, and in the data visualization also it is used. We make the relation between the tables. We make the relation between the tables. What do we do now? We will make it like a star schema. So how do we make it like a star schema? So we put the fact table in the middle. Okay, what is a star schema? Fact table is surrounded by the dimension table where we make the relation between the primary key and foreign key. We make the relation between these two tables by using the primary key and foreign keys. Fact table would have fact table would have fact table would have foreign key. Dimension table would have primary key. Okay, what do? We make the relation between these two tables based on the fact and dimension, foreign key and primary key. Customer ID and customer ID. Yes, we make the relation between these two tables. How do we make these relationship? Let us see that. How do we make these relationships? Let us see that. There are, so I can go to modeling. Okay, either I can come to data model view, click on manage relationship, click on new relationship. From table is, always remember, from table should always be the fact table because we should not miss any transactional data. So that is the reason what do? We select insurance policy detail table, that is fact table, to table, that is dimension table. Yes, it is automatically identified. Yes, it is based on the IDs, it is automatically identified. And we got the cardinality. What is the cardinality? It is many to one. Why it is many to one? There are multiple related records in the fact table and there is a unique record in the dimension table. So that is the reason Power BI automatically identified the cardinality as many to one. Okay, and cross filter direction. How do we want to make the flow of data? We will see. Let me make it single direction, and in the practical I'll show how this single direction affect in filtering the data. Okay, for now let me go for single direction. Okay, let me click on okay, let me click on save. Yes, we made the relation between the fact table, the insurance, and the customer table. Now let me arrange all these tables in the way of star schema. Let me put it, okay, let me put it, let me little collapse it. Let me move this little above and let me move this to the left side. Okay, let me arrange all the tables in a right way. Okay, let me pull it down. Let me also bring this over here. Okay, do we have any other? No, we have all the tables that I arranged. Let us make it into star schema. Okay, let us make like a star schema. Let me put it down. Let me put it to this side and I can put it policy type on the top. Okay. Here one, two tables and here one more table. Yes. On the top and on the bottom, we have it. So what do we need to do here? We can go for making the relation between the tables. So how do we do that? So let me increase it. So we can also do it by another way. Just drag and drop. So we made the relation between the customer detail table and insurance detail table. Now let us go through agent code and also one more agent code, that is sales agent code. Okay, drag and drop it. Drag and drop it. Yes. Now you see many to one. Let me click on OK. Save this. Okay, save this. Yes, we made the relation between the tables. So let me go to report view and explain how it works. Okay, let me go to report view, how data modeling works. From the fact table, select the table visual, click on the customer ID. Click on the customer ID. Let me go for sum assured amount. For now, let me go for sum assured amount. Increase the font size. Let me increase the font size to 15. Yes, we have the font size 15. This is customer ID from the fact table. And the next one is from the customer detail table. Let me also get customer ID from here. Okay, for our understanding, what I do, I will add one more customer ID. Okay, this time I will go for count. This time I will go for count. So if you observe here, there are 9,945. 9,945. Total customers are, how many customers are there? 9,945 customers are there. Let me click on customer 100,107. Yes, it is getting filtered. Okay, this one, it is getting filtered. Okay, let me take this off. Let me click on customer. Okay, customer 100,107. Oh my God, this customer is not getting filtering. Okay, dimension table. This is dimension table. This is fact table. Okay, what is the direction that we gave? Single direction. What that direction represents? Dimension table. Okay, dimension table can filter fact table, but fact table cannot filter dimension table. Okay, fact table cannot filter dimension table. I clicked on 10017, but it should filter 10017, but I'm not able to get. Go to model view, click on this and make it bidirectional. Let me go here. Now you see it is getting filtered. 100,128. Yes, 100,128. 100,371. Yes, it is filtering. Here, if I click on this, yes, it is filtering. Okay. But what is the usage? Again, if you ask me, what is the usage? Okay. So again, if you ask me, what is the usage? Let me pull it down. But how does it work? How does it work for other tables also? If you see, let me go for single direction only. There is no relation between customer table and insurance detail table. No relation between customer table and insurance detail table. But how this customer table can filter? I want to know who are all the customers by sales agent. Okay, I took the policy. My sales agent is one candidate. So with that sales agent, I got the policy. If I want to analyze the data, who are all the customers under the sales agent? Who are all the customers under the sales agent? How do we do that? Let me do one thing. Let me add sales agent. Let me take the table and add sales agent. Where is that sales agent table? Insurance agent. Agent code, sales agent. Let me click on customer. The customer table is filtering. Let me click on one candidate. Okay, let me filter one candidate. Filter one sales agent. Okay, Samarth. I filtered Samarth. Okay, I'm not able to see any. I'm not able to see the customers falling under Samarth. I'm able to see. I'm able to this table. This table is filtering diamond fact table. Okay, this table is filtering fact table. How do I get to know? Let me add the total. We will have the total. Okay, total we will have the total. So let me add the customer ID. Let me also add the customer ID over here. Count of customer ID. Okay, we are not getting the count of customer ID. Yes, we got the count of customer ID. That is 229. Okay, under the Samarth there are 229 customers. Under other route, there are 550 customers, but I am not able to get this table. Sales agent table is not able to filter customer table. But why? What is the reason? Okay, what is the reason? Because of the direction. Okay, now you remember other route. Okay, so what is the main motto here? We need to this table whether it filters the customer table or not, or remember that. Let me click on this, make it bi-directional, and again here also make it both bi-directional. Go here. Now you see 550, 550. Okay, did you see how it is getting filtered? You observe this. This is the real time scenario that you also get it in the interview. So you see, agent code is filtering the customer table. Agent code is filtering the customer table. How it is filtering? It is filtering based on the associated data that the data is passing. How the data is passing? The data is passing from, okay, the data is passing from the customer table or the sales agent data. This sales agent filtering the data. Okay, the associated agent code, associated customers. Okay, sales agent has the associated customers. This associated customers filtering the customers in the customer table. Okay, that is how the single or bidirectional cross filter direction, cardinality and cross filter direction works in the real time. Now let us make the relation with others. Policy type code and the policy type code. Okay, where is that policy type code and policy type code? drag and drop policy type code, and it works throughout all the data. So we put both so that the data is used, the column will be used for filtering the data throughout all the tables, throughout all the tables. Next one is zonal manager. Where is that? RMID, we have RMID. Where is zonal manager ID? Where is that? Zonal manager ID. But don't we have the zonal manager ID? RMID. We have RMID, sales agent code, RMID. So I can make the RMID and regional manager ID. Yes, we made the relation between the tables. We need to put it as a single direction, both direction, make it both direction. Yes, we made it. Policy code. Where is the policy code? The policy code, let me search the policy code. Where is the policy code? Yes, the policy code and the policy code. Click on, make it bi-directional and click on OK. Yes, we made that. Let me check whether we have the zonal manager code or not. Yes, we have zonal manager code. But where is that zonal manager code? Yes, here we have it. Zonal manager ID and zonal manager ID. Yes, click on it. Yes, we made the relation between all the tables. But how does the data travel in between all these tables? The data travels based on the associated data. Everything. Okay. These dimension tables would filter. Okay. Would filter all the data. All the data. Okay. In the fact table. This, the codes, whatever the foreign keys that we have, these foreign keys can also control, can also filter the other data in the dimension data also. Okay, the dimension data also. And you see the direction is both direction, both direction, both direction. So by this, what happens? The data travels between all the tables. Why this data modeling is important? The data modeling is important in further analysis when we try to implement the DAX and also in the at the time of visualization. So this is about the data modeling. All of you, are we clear till now? Are we clear till now? Why do we go for direction, single direction or both direction? So directly or indirectly, what do we have? We have the relation between these two tables. Okay, we have the relation between these two tables. We do not make the relation between dimension and dimension. We have the relation between these two. We have the relation between these two. We have the relation between these two. Okay, directly. What is the main? It is like a bridge between all the tables. Okay, it is like a bridge between. When we want to travel in between cities, so it is like a junction. Okay, when we travel in the railway, in the train, so we see the train wait at the junction because what do we think? That other trains are moving in the same direction. Okay, so the way we have the railway tracks, so here also the same thing.